Did you know that a huge part of the Amazon rainforest actually gets its food from the Sahara? It's one of the wettest places on Earth. It sounds like a science fiction story, but it's real. Tiny, almost invisible particles of dust travel thousands of miles through the air. They carry a secret that connects continents. This isn't just any dust, not the stuff under your bed. This is special dust, packed with minerals and life-giving nutrients. It's basically a global delivery service run by the wind, and it has a massive impact, from the smallest plankton in the sea to the tallest trees in the jungle. To understand where this dust comes from, we need to travel back in time. The Sahara Desert wasn't always the dry, sandy place we know today. Thousands of years ago, it was a lush landscape of rivers, vast lakes, and grasslands teeming with life. One of the most important sources of dust is the Bodel Depression in Chad. This area was once Mega Lake Chad, a gigantic prehistoric lake larger than all of the North American Great Lakes combined. As the climate changed and the lake dried up, it left behind a massive basin filled with the skeletons of tiny single-celled diatoms. These diatom skeletons are the secret ingredient. They are made of silica and are incredibly rich in phosphorus, a key nutrient that is essential for all living things. The process of lifting this dust is a powerful display of nature's force. It often begins with intense thunderstorms that form over the desert. The storms create strong downdrafts of air that hit the ground and spread out horizontally, creating a massive wave of wind called a haboob, or dust storm. They scoop up millions of tons of dust and inject it high into the atmosphere, where it can be caught by the prevailing trade winds that blow consistently from east to west. The journey of Saharan dust across the Atlantic Ocean is a true marathon, covering more than 3,000 miles. This isn't a quick trip. It can take a week or more for the dust to travel from the coast of Africa to the shores of the Americas. The dust travels within the Saharan air layer, a special atmospheric corridor. This layer of hot, dry air acts like a protective shield. The primary engine for this journey is a set of powerful, reliable winds called the trade winds. These winds blow consistently from the northeast in the northern hemisphere, pushing the dust plumes steadily westward. The path of the dust changes with the seasons. In the winter, the dust tends to travel farther south, reaching the Amazon rainforest in South America. In the summer, the plumes shift northward, often reaching the Caribbean, the Gulf of Mexico, the southern United States. As the dust travels, it doesn't just stay the same. The journey itself transforms the dust cloud. The heavier particles, like larger grains of sand, tend to fall out of the sky closer to Africa, dropping into the eastern Atlantic. Scientists use satellites like NASA's Calypso, which uses lasers to create a three-dimensional map of clouds and aerosols to measure just how much dust makes the trip. Long before the dust ever reaches land, it provides a crucial service to the ocean it flies over. The surface of the open ocean can be like a desert, beautiful but empty of the nutrients needed for life to thrive. The most important of these missing nutrients is often iron. Just like we need iron in our blood, tiny marine plants called phytoplankton need iron to grow and perform photosynthesis. Phytoplankton are the foundation of the entire marine food web. They are the grass of the sea, eaten by tiny animals called zooplankton, then eaten by small fish, then eaten by bigger fish, all the way up to sharks and whales. When Saharan dust falls from the sky and lands on the ocean's surface, it's like a vitamin sprinkle from above. The dust is rich in iron, and as it dissolves in the seawater, it provides an instant feast for the waiting phytoplankton. This triggers enormous blooms of these microscopic plants, turning patches of the ocean into a vibrant green. These blooms are so large they can be seen from space. It's a spectacular example of how a non-living mineral from the land can spark a huge explosion of life in the sea. During photosynthesis, phytoplankton absorb carbon dioxide from the atmosphere, just like trees on land. When these organisms die, some of them sink to the deep ocean, taking the carbon they absorbed with them. This process is called the biological carbon pump, and it's one of the Earth's most important mechanisms for regulating the climate. The Amazon rainforest is one of the most vibrant and biodiverse places on Earth, a world of constant growth and cycling life. But all of this growth comes at a cost. The region gets so much rain that nutrients are washed out of the soil and carried away by rivers into the ocean. Over thousands of years, this left the Amazon soil surprisingly poor, especially in phosphorus. This is where Saharan dust comes in, acting like the Amazon's fertilizer delivery service. Each winter, trade winds lift phosphorus-rich dust from the Bodel Depression and send it to the Amazon basin. As dust settles on leaves or is washed to the ground by rain, it replenishes the phosphorus the ecosystem loses each year. It's a long-distance partnership. Scientists calculate the dust delivers about 22,000 tons of phosphorus per year. That's roughly the same amount the Amazon loses to rainfall and flooding. The desert is literally feeding the rainforest. This dusty gift helps maintain the Amazon's incredible biodiversity. The dust supports plant growth from towering canopy trees to delicate orchids on branches. That plant life provides food and shelter for animals, monkeys, jaguars, parrots, and millions of insects. The discovery is a science detective story. For years, scientists were puzzled how such poor soil could support so much life. The answer came from combining different fields. When the pieces were put together, Africa was fertilizing South America, a mind-blowing connection that rewrote how we understand planetary systems. The impact of Saharan dust extends beyond feeding living ecosystems. It also helps build the very land itself. In the Caribbean, many of the beautiful sandy beaches and the soil on islands like Barbados are not from local rock. Instead, a significant portion of their soil is composed of mineral dust that has traveled all the way from Africa over millennia. Each time a dust plume arrives, it deposits a tiny new layer of material. Over thousands and thousands of years, these tiny deposits add up, contributing to the soil that allows agriculture to flourish and forming the foundation of entire island landscapes. On a more immediate and beautiful note, Saharan dust is responsible for creating some of the most stunning sunsets and sunrises you will ever see. When a dust plume moves into an area, the tiny particles in the air act as a natural filter for sunlight. They scatter the blue-green wavelengths, while allowing the red-orange-yellow wavelengths through. During a dust event, the sky can look hazy and milky by day, then erupt into fiery, vibrant shades of red and orange as the sun gets low on the horizon. Next time you see a spectacular sunset in summer in Florida, it might not just be the clouds. You could be witnessing the grand finale of a 3,000-mile journey. Those colors are painted by tiny particles of a distant desert, a final, beautiful goodbye before they settle on land and ocean. While Saharan dust brings many benefits to our planet's ecosystems, its arrival can be a mixed blessing for human health. The same tiny particles that carry nutrients can also cause problems for people, especially those with respiratory issues. The dust is a form of particulate matter pollution, known as PM2.5 PM10 particles small enough to be inhaled deep into the lungs. When dust concentrations are high, air quality can plummet, leading to health advisories for people to stay indoors. For people with asthma allergies, other chronic lung conditions, a Saharan dust plume can trigger serious symptoms. These can include coughing, wheezing, shortness of breath, irritation of the eyes, irritation of the nose, irritation of the throat. But the story isn't all negative. In a surprising twist, the dust may also have a protective effect. The dry, hot Saharan air that carries the dust across the Atlantic can suppress hurricane formation. Hurricanes, tropical storms, need warm, moist air to form and strengthen. The Saharan air layer is the opposite, warm but incredibly dry, and it contains wind shear, which means the wind speed and direction change with height. Dry air plus wind shear can disrupt a budding tropical storm, tearing it apart before it grows into a powerful hurricane. During peak hurricane season, a thick dust plume can bring a sigh of relief to coastal communities. While it may worsen air quality for a few days, it can act as a temporary shield against a much more destructive force. The influence of Saharan dust extends far beyond fertilization sunsets. It's a major player in the Earth's weather and climate system. The massive plumes of dust are not just passive travelers, they actively change the atmosphere they move through. One of their most significant effects is on cloud formation. Dust particles act as cloud condensation nuclei, tiny surfaces, where water vapor condenses, forming cloud droplets. More dust leads to clouds with many smaller droplets. Clouds made of many small droplets are brighter, they reflect more sunlight back into space, unlike clouds with fewer, larger droplets. A dusty sky can cool the ocean and land below. Dust also interacts directly with solar energy. Dark, iron-rich particles absorb solar heat, warming the atmospheric layer where the dust sits. This creates the warm Saharan air layer, which helps suppress hurricanes. Scientists use complex computer models to understand these interactions and predict future climate impacts. We can't think about climate just in terms of greenhouse gases. Natural aerosols like Saharan dust matter a lot. Dust amounts vary with rainfall in the Sahel and with wind patterns. A wetter Africa could mean less dust, which could mean a warmer Atlantic and potentially more active hurricane seasons. Understanding these feedback loops is a cutting-edge frontier revealing the planet as a giant, interconnected weather machine. The journey of Saharan dust is more than just a scientific curiosity. It's a powerful story about connection. It teaches us that no ecosystem is truly isolated. The health of the world's largest rainforest is tied to the dust from one of the world's largest deserts. The abundance of life in the middle of the ocean depends on minerals carried on the wind from a distant continent. The color of our sunsets, the quality of our air, even the intensity of our storms. It's a profound reminder that the Earth functions as a single, integrated system. This invisible river of dust challenges us to see the world differently. It encourages us to look for the hidden connections that are all around us, linking oceans, forests, deserts, and even our own bodies. The phosphorus in a leaf in the Amazon may have once been part of an ancient lakebed in Chad. The iron that fuels a phytoplankton bloom in the Atlantic could have been scraped from a North African mountain. We are all part of this planet-wide exchange of materials. This perspective inspires a sense of wonder and humility, showing us how intricately woven the web of life truly is. So, the next time you see a hazy sky or a brilliantly colored sunset, take a moment to wonder. As our planet changes, this ancient connection may change too. By studying the secret life of Saharan dust, scientists are not just uncovering the secrets of the past, they are gathering vital clues about our future. Think about the incredible journey those tiny dust particles have taken to reach you. Think about the desert they came from and the rainforests and oceans they are on their way to feed. Let it be a reminder of the amazing hidden forces that shape our world. The Earth is full of these secret stories and invisible threads that tie us all together. And the greatest adventure of all is discovering them, one particle of dust at a time. The world is full of wonder if you just know where to look.